Assalamualaikum, students and friends. Welcome back to Sir K Loves Physics tutorial. Today's episode is a sequel to a past upload on the relationships of linear and angular kinematics quantities. So just sit back, relax, watch and learn. Question number 1. A boy and a girl are riding on a merry-go-round which is turning at a constant rate. The boy is near the outer edge and the girl is closer to the center. Question is, who has the greater, letter A, angular displacement, letter B, angular speed? Letter C, who has the greater linear speed? Letter D, who has the greater centripetal acceleration? And letter E, who has the greater tangential acceleration? Before we answer question number 1, let's first take a look at the summary of kinematics equations, which was first shown in the past episode on linear and rotational kinematics. We pay attention to some of them that relate linear and angular quantities, such as um, delta D equals delta theta times r, or the change in linear displacement or distance is just equal to the change in angular displacement times the radius r. Next, we also have the linear speed or velocity v, which is equal to the angular speed or velocity omega times the radius r. The third equation is centripetal acceleration equal to the square of the angular speed or velocity times the radius r. And lastly, we also take note of the equation omega squared equals omega naught squared plus 2 times alpha times theta. So for the first question, number 1, the merry-go-round is turning at a constant rate. This means um, the angular speed or angular velocity omega of the merry-go-round is constant throughout the motion. Hence, we say that the angular displacement delta theta is the same at the outer edge and at a point closer to the center, regardless of their difference in the distance from the center. Therefore, our answers to questions A and B are the boy and the girl, right, have the same angular displacement, and they also have the same angular speed or velocity. For question letter C, who has the greater linear speed? All right, so linear speed, denoted by small letter v, is just equal to omega times r, or the angular speed times the radius. All right, radius here is defined as the distance from the point in question to the center of the merry-go-round. Right? The center of the merry-go-round acts as the axis of rotation. Right? Now, since the boy is at the outer edge, all right, which has a corresponding radius or distance from the center that is greater, all right, compared to that of um, the girl, we say therefore that between them, the boy and the girl, it is the boy who has the greater linear speed. All right. Now, for question letter D, who has the greater centripetal acceleration? All right. Centripetal acceleration, which is a linear acceleration denoted by a sub c, all right, it is equal to the square of the angular speed omega multiplied by the radius r. Hence, we also say that the boy has the greater centripetal acceleration than the girl does. Okay? And for question letter E, who between the boy and the girl has the greater uh, tangential acceleration? All right? Now, tangential acceleration denoted by a sub t is equal to 0 when the angular speed or velocity of the rotating body is constant. All right? So if there is no change in the magnitude of the angular speed or velocity, we say that the tangential acceleration a sub t is equal to 0. All right? So, our answer to letter E, who between the boy and the girl has the greater tangential acceleration, all right, our answer is that uh, there is none, all right, because both the boy and the girl has 0 tangential acceleration, all right. So we say that for a body in uniform circular motion, the only acceleration it has is the centripetal acceleration, all right, a sub c. But there is no tangential acceleration because the magnitude of its tangential velocity is constant. And that's also true for a body that is rotating at constant angular speed or angular velocity. All right? The angular acceleration is 0. So, the tangential acceleration must be equal to 0. All right? Moving on to our last question, number 2. A wheel of diameter 68.0 centimeters slows down uniformly from 8.40 meters per second to rest over a distance of 115 meters. Question is, what is the angular acceleration? Option letter A, negative 1.80 radian per second squared. Option letter B, negative 0.903 radian per second squared. Option letter C, negative 5.65 radian per second squared. Or option letter D, negative 11.3 radian per second squared. All right, so in problem number 2, we are given the following. The diameter of the wheel is equal to 68.0 centimeters, so that makes its radius equal to 34.0 centimeters. Its initial linear speed v naught is equal to 8.40 meters per second, and the final linear speed v is equal to 0 since the body comes to rest. All right. This initial speed v naught refers to the tangential speed of a point at the rim of the wheel 34.0 centimeters from the center. All right. So its final tangential speed v is equal to 0. Now, the linear distance traveled by this point before coming to rest is also given 115 meters. And our target variable is the angular acceleration denoted by alpha. Right? So, our solution, we first uh, compute the initial angular speed omega naught using the formula omega naught equals the linear initial speed v naught divided by the radius r. That is, omega naught equals 8.40 meters per second divided by 0.340 meters. So doing our math, we will get the magnitude of the initial angular speed equal to 24.7 radians per second. Next, we will determine the angular displacement denoted by theta. All right, using the formula theta equals the linear distance divided by the radius r. So that means 115 meters divided by 0.340 meters. And our computed angular displacement theta equals 338 radians. All right, so we can now use this formula in finding the angular acceleration alpha, right? This angular acceleration alpha is just equal to the square of the final angular speed, which in this situation is equal to 0. All right? Then minus the initial angular speed square. That will be divided by twice the value of the angular displacement theta. All right? Substituting, we get alpha equals 0 minus the square of 24.7 radian per second, and that will be divided by twice the value of the computed theta, 338 radians. So again, doing our math, we will arrive at the value of the angular acceleration alpha equal to negative 0.903 radian per second squared in three significant figures. That means our answer to question number 2, what is the angular acceleration? Alright, the correct answer is option letter B, negative 0.903 radian per second squared. So that's it, we're done. Until the next episode, mabuhay, Masya Allah. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.